So oscilloscope. Okay. So last class we discussed with the different multimeters. In this class, we are going to discuss about oscilloscope. So oscilloscope mainly used for display the signals. Okay. So if you want to see the signals, that is sine wave, square wave, triangular wave, like that. If you want to see the different waveform means you have to use the oscilloscope. So there are two types of oscilloscope available. One is normal oscilloscope, and one is digital oscilloscope. That is called a DSO. That is digital oscilloscope. Okay. So let's see the internal diagram of the oscilloscope. Okay, first, before that, we will see the definition. So oscilloscopes convert the electrical input signal into a visible trace on the screen. So they convert the electricity into the light. So oscilloscope dynamically graph time varying electrical signals in two dimensions. So typically voltage-based time. So oscilloscopes are used by engineers and technicians to test, verify, and debug electronic designs. So oscilloscopes will be the primary instrument that you will see, that you will use in your physics lab to test assigned equipments. So these are the different oscilloscope in the different models. So probe model for getting the data from the particular circuit. So understanding the scopes display. So that is we can calculate through the values. So like that we can define. That is primarily of the oscilloscope setup. So that is it is have trigger level, horizontal position, vertical portion, like that it is having. This is the block diagram of oscilloscope. Okay, that is DSO, that is digital storage oscilloscope. So in previous model, in initial model, the oscilloscope with the CRT monitor. So the power, the electron gun, the power variations will be given to the excited plates. That is the plates having the more power. Okay, so that is plate A, that is horizontal plates and the vertical plates. Using these plates, the electron beam will be direct to the particular location. Like that, we can get the output. But in digital storage, we need to get the sample of the input. என்ன பண்ணணும் we need to get the sample. ஸோ அப்போ அந்த டேட்டாவை எடுத்து அதை நான் வந்து ஒரு டிஜிட்டலாக கன்வெர்ட் பண்ணி ப்ரீவியஸாக இருக்கிறோட வேல்யூ நான் வந்து என்ன பண்ணணும் கம்பேர் பண்ணணும். ஸோ we need a lot of models, that is attenuator, DC offset values, amplifier, trigger coupling, trigger logic, time-based system, 8-bit ADC, then display, DSP, and scope display. So oscilloscope performance specification. The bandwidth is the most important oscilloscope specification. So that is a Gaussian frequency response, V out divided by V in. So selecting the right bandwidth through the using of scope. So other important specification is waveform update rate. So faster update rates enhance the probability of capturing infrequently occurring circuit problems. The display quality, that is size, resolution, number of levels of intensity graduation. So advanced triggering models. So time qualified pulse widths, pattern, video, serial, pulse violation. That is pulse violation means edge speed, setup, hold time, run. So compensating the probes. So proper compensation. So connect channel 1 and channel 2 probes to the probe comp terminal. So adjust V divided by V division, S divided by division, now to display 4 waveforms on screen. So using a small flat blade screwdriver, adjust the variable probe compensation capacitor on both probes for a flat response. Yeah, this is the models we are compensating the probes, because initially it is having the different circuits. So using probe measuring concept, we can define the particular values. Okay. Thank you. So next class we will see the recorders.